Hello girls, we're looking at force summation today, and I'm actually watching the cricket at the same time, and I'm watching the cricket players are trying to apply lots of force summation to that cricket ball. To apply force summation, you've got to generate a large amount of momentum, and you start with the largest muscles first and moving through all the body parts from the legs to the hips, to the trunk, to the shoulder, to the elbows, and finally the wrist. It's with the javelin throw, as you can see in the picture here, and even with the New Zealand batting team trying to beat Australia right now. So the first question we're going to look at is sequencing of body segments. When trying to give an object as much momentum as possible when you're throwing or hitting, as in cricket at the moment, we should use as many body segments as possible. However, they have to be used in the correct order so as to maximise the force that can be generated. So when we're throwing the javelin, as in our first question, the order is very important. So number one, question A, consider the person throwing the javelin. What is the order of body segments in the throwing action? Well, it would start off with the largest muscles first, which is the legs, then the hips, trunk, shoulders, arms, wrist, and finally the javelin. And that would give maximum force to the javelin when he throws it. Question B is, what would be the effect if the sequencing of segments was incorrect? Well, it'd be an uncoordinated movement and a loss of force being generated. So you can answer those in your book. I'll give you some brief answers here. A, want that bit. So in order to generate maximum momentum, the smaller body parts that can move fastest, such as your hands when you're throwing the javelin or your feet when you're kicking the soccer ball, must be used towards the end of the sequence. Therefore, the larger muscle groups should be used early in the sequence, in effect, so that the body is like a whip and it is creating lots of energy. So the answer to number 1C is by generating large amounts of momentum in by generating large amounts of momentum in large muscle groups. This can be passed to a smaller body part. It must move faster because it is lighter for total momentum to stay the same. Number 2, stretching out. When we throw a ball, what effect does it have if the arm is too extended or flexed initially? Well, it will mean that we cannot generate enough force if you've got too much extension or you are too flexed. So you're not stretching out properly, you're not making the most of it. Therefore, we have to ensure the body is stretched its very best, optimally stretched out in order to generate maximum force across a joint. Stretching out creates an elastic potential energy. It suggests that stretching out muscles out to not more than 20% of their resting length will generate maximum force on contraction. This means that the lever will be able to generate more power. Right, we're top of page 76, 2B. How has the baseball pitcher applied the principle of stretching out to maximise the force they can generate throughout the body? Well, as in the picture, you can see that by bringing the arm back just enough to get maximum force at the start of the throw, he can generate more force that way. And how have they applied the principle of sequencing of the body? Remember, sequencing is one of the key words. It's the sequence that we use all our muscles in. And so the sequence here for the transfer of force is legs, hips, trunk, shoulders, arms, hand, and finally it's applied to the ball. And the last point we're making for force of summation is that to use a full range of motion. So as you can see in our softball picture here, she's got extended arms, a very long lever. We're calling her arm a lever. Very soon we'll be going on to learn about levers, and there's a little phrase of mine which I always hammer into people: the longer the lever, the greater the speed at the end of the lever. And here we've got the full range of motion and the force summation being released at the end of a long lever. So it means that moving an object through a full range of motion can lead to greater momentum because it's got a longer lever. So the answer is, it means that the longest possible lever can have a longer path to travel, meaning it can generate greater velocities. So the key to this is the longer the lever, the greater the speed at the end of the lever. And in this diagram, the lever is actually, her arm is the lever that we're referring to. So she's got a fully extended arm before she releases that ball. We're up to the summary now, where you've got to put all these principles together, the principles of sequencing of body movements, stretching out, and full range of motion. Putting all those principles together to explain how this soccer player is, what happens when he strikes the football. Some of the key things you need to look at is that the player is bending his kicking leg enough so that the quadriceps can generate large forces when it contracts. The forces generated start at the hip, trunk, thigh, then lower leg, foot, and then the ball. By drawing the leg back with extension, it's extension of the hip, they get a full range of motion of the foot on contact. Bending the kicking leg also decreases in inertia, meaning it can generate more angular velocity. Give that a go at writing that all down, and let's see how you get on. So we'll just go over that again. You've got to start with the flexed, with a flexed knee, and then so to generate forces, the forces start with the hip and the trunk, and then the thigh, lower leg, foot, then the ball. That's generating the forces sequentially. And by drawing the leg back, that's hip extension, you get a full range of motion on the foot. And then we'll just go on to the next slide, where we're talking about there's flexion of the knee, and that decreases the inertia, meaning that the foot can generate more angular momentum. The word inertia means resistance to change. So if we stretch our arms out right wide and try and do a pirouette, we won't go round very slow. We'll go round very, very slowly. But if we try and do a pirouette, you can imagine me doing one, and my arms are tucked in around my body tight, I will spin more rapidly. So I'm not taking up so much space either. So I've got less inertia. I've decreased my inertia. And the same with the leg. By flexing the knee, I'm decreasing the inertia of the leg, and the leg is able to move at a greater angular velocity. And that is, angular velocity means the velocity means speed, and the angular is because it's not in a straight line, there's angle to it. You're moving through a curve. So flexion of the knee decreases inertia, it reduces the inertia, meaning the foot can move faster and can apply greater force to the ball. Well, that's all for today, and you are to make sure you have all those notes in your book and complete it, and we will go over it in class. You need to be able to apply that to your sport that you're going to be practicing next term.